In this video, we are going to see two important line drawing algorithms and two important circle drawing algorithms. So to start with, we start with the first line drawing algorithm, that is DDA algorithm. DDA stands for Digital Differential Analyzer Algorithm. So what is this algorithm all about? The algorithm is very simple and it depends upon the term m, that is nothing but the slope of the line. So what is the formula for m? M is delta y upon delta x. What is delta y then? It is y2 minus y1 and delta x is x2 minus x1. So in DDA algorithm, whether it is delta y or delta x, whichever is larger, it is chosen to be the one raster unit. Now what is the meaning of one raster unit? We will understand when we look at the algorithm. So the very first step of the DDA line drawing algorithm is that we have to check whether our endpoints of the line, that is x1, y1, the starting point, and the ending point x2, y2 should not be equal. Because if they are equal, you will in turn be just plotting the point. So once we have ensured that our x1, y1 and x2, y2 are not equal, we go ahead and calculate delta x and delta y. Again reiterating the formula for delta x and delta y, delta x is x2 minus x1, delta y is y2 minus y1. Now next thing we need to do is we need to check whether delta x is greater than delta y. So the condition is if delta x greater than or equal to delta y. If this is the case, if the condition is true, then the variable length is equal to delta x. Otherwise, else the variable length will be equal to delta y. So whichever is greater, delta x or delta y, the length variable is initialized to that. Now, the new value of delta x and delta y is to be calculated. How do I calculate it? Delta x is equal to x2 minus x1 divided by the length, which we have just now calculated, and delta y is equal to y2 minus y1 divided by length, again which is calculated just now. So above we had seen that it becomes one raster unit. So how does it become one raster unit? Just imagine if length is equal to delta x, then delta x upon length will obviously become 1. Same case happens if length is equal to delta y, that new delta y becomes 1. Depending upon the case, this decision is taken. Now, the actual line drawing process goes as follows. We initialize I, which is our iteration variable, I is equal to 1. The condition is I is less than equal to length. So the loop will continue working till I is less than or equal to length. We plot the point x comma y. Integer method is used over here to specify that even if it is a floating point number, you have to convert it into an integer. The new x value is calculated as x plus delta x. The new y value is calculated as y plus delta y. I is equal to I plus 1 and then we eventually stop. So this was all about DDA line drawing algorithm. Now we slowly go ahead with the advantages and the disadvantages of the line drawing algorithm. What are the advantages and disadvantages of this algorithm? The advantage is that it is very simple. The method of calculation is fast because we are using the direct equation for the line. Increment happens easily, but at the same time, the major problem over here is we are using floating point arithmetic, which is very time consuming. Another problem with this algorithm is it is orientation dependent, indicating that the endpoint accuracy is poor depending upon the type of line we are trying to draw. So if it is a vertical line or a horizontal line or it is a 45-degree slant line, then it is okay. But if very steep lines are there, then the endpoint accuracy is poor. So that is all about DDA line drawing algorithm. Now we move ahead with Breschenum's line drawing algorithm. Breschenum line drawing algorithm says that we will use only integer arithmetic and that also major focus is on addition and subtraction operation and multiplication by 2. So these operations are quite rapidly performed by your system. So if I compare DDA line drawing and Breschenum's line drawing, Breschenum line drawing will give you a better output. Okay. So what we do over here is, we try to calculate the distance DA and DB, and whichever distance is smaller, okay, suppose DA is smaller, then we consider the above pixel. If DB is smaller, then we consider the below pixel. So depending upon the distance DA and DB, we find out which pixel is more closer to the line, and we color that particular pixel, or we say that the line is passing through that particular pixel. Now for doing this, we have a term which is called as E. E is called as the error term or the decision variable in Breschenum line drawing algorithm. So if you carefully observe the first two steps, rather first three steps of this Breschenum line drawing algorithm, you will see that they are exactly as same as your DDA line drawing algorithm. You want to take the endpoints of the line x1, y1, x2, y2. Check if they are not equal. If they are equal, then you pull out the point and exit. Later on, you go ahead and you calculate delta x and delta y. The formula again remains the same. It is x2 minus x1, y2 minus y1. You initialize the starting point. X is equal to x1, y is equal to y1. And now from step number 4 onwards, the algorithm changes. The base equation for the error or the decision variable is 2 into delta y minus delta x. Then you initialize the counter, you plot x comma y, and you go ahead and you check the error term. If e is greater than or equal to 0, then y is equal to y plus 1. A new value of e is calculated. E is equal to e minus 2 into delta x. This loop will go on till this condition is true. As soon as this condition becomes false, we will come back, or we will come out of the loop over here. So x is equal to x plus 1, e is equal to e plus 2 into delta y. Then you do I is equal to I plus 1, and the stopping condition over here is I is less than equal to delta x. If this condition is true, I will go up, I will plot x comma y, and this entire thing will continue to work from step number 9 to step number 6. Everything will be repeated again and again till this condition is true. Once this condition goes false, we will stop drawing the line. So this was about Breschenum line drawing algorithm. Moving ahead, we try and understand about circle drawing algorithms. Now drawing circle is quite easier because we don't draw the complete circle, we draw only 1/8 portion of the circle. This is because the circle exhibits a property which we call as 8-way symmetry of circle. So we draw the circle from 90 degrees to 45 degrees only. You can see the markings I am making on the screen. This is the only set of or only points we need to actually calculate. The rest of the points are going to be drawn as per these coordinates which are given to us. Now when I am drawing a circle from 90 degrees to 45 degrees, x is going to move in a positive direction and y is going to move in a negative direction. Once the 1/8 part of the circle is drawn, the rest of the job is very simple. You simply plot these points like y comma x, minus y comma x comma minus y, so on and so forth. Now, again we are going to see two circle drawing algorithms. The very first one is Breschenum circle drawing algorithm. Now in Breschenum circle drawing algorithm, we try and use the similar concept as with the Breschenum line drawing algorithm, which said that you calculate DA and DB. So here we again have an error term and we calculate the dA and dB, and depending upon that we try and make these decisions. So we have two options. The option 1 says that you increment only in the positive x direction by 1 unit, else you increment in the positive x direction by 1 unit and decrement the y by 1 unit. So negative by y by 1 unit. So you have to make this decision whether only to increase x or to increase x as well as decrease y. So how we are making this decision? We are making this decision depending upon the distances dA and dB. So let us see the Breschinum line drawing algorithm. The first step of Breschinum line drawing algorithm is that you calculate, or rather you take radius as the input. So I am taking radius r as input for drawing my circle, and now I calculate the decision variable, that is d, which is equal to 3 minus 2r. Now in Breschinum circle drawing algorithm and midpoint circle drawing algorithm that we are going to see next, this d is going to be different. So be very careful which algorithm, what is the initial value of d. So if it is a Breschinum circle drawing algorithm, then it is 3 minus 2r. Remember, how do you write b? You write b like this. So you write it 3 minus 2r. Okay. So initialize the starting point. What is the starting point? X is equal to 0 and y is equal to r. Now you are going to use a do while loop. So do plot the point x comma y. Check the condition. If d is less than 0, then you just update the decision variable. It becomes d plus 4x plus 6. Else d becomes d plus 4 into x minus y plus 10. And y is equal to y minus 1. These equations and this equation is something you need to very thoroughly remember. Then you do x is equal to x plus 1 in both the cases, and your stopping condition is x is less than y. As soon as y becomes equal to x, you stop. Till the point x is lesser than y, you continue performing the algorithm. Now, the last algorithm that we have is the midpoint circle drawing algorithm. The difference between the midpoint circle drawing algorithm and the Breschinum algorithm is that the reference point that we consider. Okay? If we are considering the midpoint as the reference point, then it becomes midpoint circle drawing algorithm. Now, what is the algorithm? If you see step number 1 and 2, it is the same. You are reading the radius, you are initializing the starting point as x is equal to 0, y is equal to r. The third step is different because the decision variable calculation is different. D is equal to 1.25 minus r. D is equal to 1.25 minus r. Now, if you carefully observe, the conditions are also similar. D is less than 0 is the condition. But what changes? This equation changes. D is equal to d plus 2x plus 1. X is equal to x plus 1, y is equal to y. Y is not changing in if, but it is changing in else. X is equal to x plus 1, y is equal to y minus 1, and d is equal to d plus 2x plus 2y plus 1. The while loop condition is also the same. So, all these 4 algorithms are very easy. You just have to remember certain equations. Another thing that you can do in this regard is, just as you have 8-way symmetry for a circle, you have 4-way symmetry for an ellipse. So, ellipse is elongated and it has 2 radii. It has rx and ry. So, why do we say ellipse has 4-way symmetry? Because we divide ellipse into 4 sections and we draw only the first section. We draw only this section and we calculate the point x comma y. Rest of the 3 points we are simply going to plot as x comma minus y, minus x comma minus y, and minus x comma y. That's it for this topic.